My name is Rohit Kumar, and today I will explain you about the factors that will affect the flame propagation during the combustion in SI engine. Rate of flame propagation affects the combustion process in SI engine. Higher combustion efficiency and fuel economy can be achieved by higher flame propagation velocities. Unfortunately, flame velocities for most of the fuel range between 10 to 30 meter per second. The factors which affect the flame propagation are air-fuel ratio, compression ratio, load on engine, turbulence and engine speed, and other factors. First of all, we will talk about air-fuel ratio. The mixture strength influences the rate of combustion and amount of heat generated. The maximum flame speed for all hydrocarbon fuels occurs at nearly 10% rich mixture. Flame speed is reduced both for lean as well as very rich mixture. Lean mixture releases less heat and resulting in lower flame temperature and lower flame speed. Very rich mixture results in complete combustion and also results in production of less heat and flame speed remains low. Now we will talk about the compression ratio. The higher compression ratio increases the pressure and temperature of the mixture and also decreases the concentration of residual gases. All these factors reduce the ignition lag and help to speed up the second phase of the combustion. Higher compression ratio increases the surface to volume ratio and thereby increases the part of mixture which after burns in the third phase. Now we will talk about the variation in load on engine. With increase in load, the cycle pressure increases and the flame speed also increases. In SI engine, the power developed by an engine is controlled by throttling. At lower load, high throttle and the initial and the final pressure of the mixture after compression decreases. And mixture is also diluted by the more residual gases. This reduces the flame propagation and prolongs the initial lag. This is the reason the advanced mechanism is also provided with change in load on the engine. The difficulty can be partly overcome by providing rich mixture at part loads, but this definitely increases the chances of afterburning. The afterburning is prolonged with rich mixture. In fact, poor combustion at part loads and necessity of providing rich mixture are the main disadvantage of SI engines, which causes wastage of fuel and discharge of large amount of CO with exhaust gases. Now the fourth factor is turbulence. Turbulence play a very important role in combustion. In combustion of fuel, as the flame speed is directly proportional to the turbulence of the mixture. This is because the turbulence increases or the mixing and heat transfer coefficient or heat transfer rate between the burned and unburned mixture. The turbulence of the mixture can be increased at the end of the compression by suitable design of the combustion chamber. Insufficient turbulence provides low flame velocity and incomplete combustion and reduces the power output. But excessive turbulence is also not desirable as it increases the combustion rapidly and leads to detonation. Excessive turbulence causes to cool the flame generated and flame propagation is reduced. Moderate turbulence is always desirable as it accelerates the chemical reaction and reduces ignition lag, increases flame propagation and even allows weak mixture to burn efficiently. Engine speed. The turbulence of the mixture increases with the increase in engine speed. For this reason, the flame speed also increases linearly with the engine speed. If the engine speed is doubled, flame to transfer the combustion chamber is halved. Double the original speed and half the original time give the same number of crank degrees for flame propagation. The crank angle required for the flame propagation, which is main phase of combustion, will remain almost constant at all speeds. This is the important characteristic of all petrol engines. Now we will talk about engine size. Engines of similar design generally run at the same piston speed. This is achieved by using small engines having larger RPM and larger engines having smaller RPM. Due to same piston speed, the inlet velocity, the degree of turbulence and the flame speed are nearly same in similar engines regardless of the size. However, in small engines the flame travel is small and in large engines is large. Therefore, if the engine size is double, the time required for flame propagation through combustion space is also doubled. But with lower RPM of large engines, the time of the flame propagation in terms of crank would be nearly same as the smaller engines. In other words, the number of crank degrees required for flame travel will be about the same irrespective of the engine size, provided the engines are similar. Now we will discuss about the other factors that will affect the flame propagation. Among the other factors, the factors which increase the flame speed are supercharging of the engine, spark timing, and residual gases left in the engine at the time of exhaust. The air humidity also affects the flame velocity, but its exact effect is not known. Anyhow, its effect is not large compared to airflow ratio and turbulence.